Hey guys, so this is your trainer Anirudh Chhillar. So today we'll be talking about EIGRP, that's Enhanced Internet Gateway Routing Protocol. So let's go, guys.
Let's start EIGRP now. Again, distance vector, but advanced distance vector routing protocol, right? Enhanced version of ICRP. Before going for EIGRP, we must understand that what are the problems with RIP, because both of them are distance vector, right? So what are the problems with RIP? Like in RIP actually there is no strong mechanism to prevent your network from routing loops. The second thing, RIP supports only equal cost load balancing, does not support unequal cost load balancing. In RIP, maximum hop count value is 15. It means you can implement RIP in small networks only. The metric is only and only hop count, and if metric is hop count only in RIP, we can have a lot of problems in our network. Let's say, as I said earlier on, R1, R2, R3, and this is serial link. This is 100 Mbps link. This is also 100 Mbps link. But still for R3 to reach R1, the best path will be via serial link only, because it will never consider bandwidth for its metric calculation. It will consider only and only hop count. So based on hop count values, of course, for R3 its best path will become, the best path to reach R1, it will be directly to R1, not via R2. That is the big problem with RIP, that it does not consider bandwidth or delay, something like that, to calculate its, for metric calculation. It considers only and only hop count value. That was the big problem with RIP actually. And also, as I said, that does not have any strong algorithm which can prevent which can prevent RIP from routing loops. So these are the disadvantages with using RIP in our network. That's why in most of the cases you will find EIGRP in your network in place of RIP, because in EIGRP, as I said, that RIP was not supporting RIP was not supporting unequal cost load balancing. Here, EIGRP supports unequal as well as equal cost load balancing both. Second, in RIP, it was considering only and only hop count value for its metric calculation, whereas EIGRP will be considering bandwidth, delay, load, reliability, MTU, all these components for its metric calculation. And in EIGRP, your metric will always be inversely proportional to your bandwidth. Bandwidth is higher, metric will be lower. Bandwidth is lower, metric will be higher. And in EIGRP, same as RIP, lower metric will always be preferred. Are you getting my point or not? So of course we will be using the EIGRP, or we will prefer to use EIGRP over RIP. The disadvantage of EIGRP over RIP is like EIGRP is Cisco proprietary, but now recently it has been launched as an open standard, but still we cannot use it as an open standard protocol. In iOS, still we are using it as a Cisco proprietary protocol, because still all other vendors are not supporting this EIGRP. And one more thing, IEEE has launched RFC of EIGRP, because for all open standard technologies they are having RFC, request for comment. But for EIGRP, still we are having only draft, not a valid RFC. We are having only and only draft. Like in our parliament, if they are going to make any rule, first of all they have to introduce a draft. Then they will discuss on that draft inside the parliament, and then finally it will become a rule, or it will take place. So right now we are having only and only draft RFC. Even you can also check it on internet as well. So still other vendors are not supporting this EIGRP, but once they were launched a valid RFC, then after you will see that all other vendors will also start to support this routing protocol EIGRP. Right now, if you talk about this EIGRP, enhanced interior gateway routing protocol, the only thing which makes it different from RIP is there are a lot of things which makes it different from RIP. You know why? Like convergence. EIGRP has fastest convergence among all IGPs. Even if you compare it with OSPF or ISIS2, then also you will come to know, you will find this EIGRP the fastest one among all. The second thing, EIGRP supports unequal cost load balancing, right? Of course, it is supporting unequal cost load balancing as well. And it is advanced distance vector routing protocol. So it is having a modified distance vector algorithm, which is known as dual diffusing update algorithm, which is really strong algorithm to prevent your network from routing loops. Like we are having concept of successor, feasible successor. To become feasible successor, there is a condition of feasibility, right? So all these things are available in this algorithm dual. So here we will be using a strong algorithm which is called dual in EIGRP. And also the hop count value is still there, because if it is a distance vector, it means it has to use hop count value. So of course, yeah, it will still be using hop count value, but not for metric calculation. But remember, it will still keep hop count information. That is why we always say that it can support maximum up to 255 hop count, but the default hop count value is what? 100. Right? Now it is advanced distance vector routing protocol, because before EIGRP, all other distance vector routing protocols were sending only and only periodic updates, like IGRP as well as RIP. But EIGRP will by default send only and only triggered update. Very first time, whenever EIGRP forms a neighborship, at that moment only it will send full update, and then after it will send only and only triggered update. Are you getting my point or not? But the problem is, like whenever neighborship will go down, it will remove again all routes from its routing table, and when neighborship will come up again it has to exactly, it has to give full update to its neighbor. Fine. In EIGRP, we are also having the concept of neighborship. In RIP, we do not have any concept of neighborship. One another advantage is also available with using EIGRP over RIP. In RIP, it was not possible to run multiple processes of RIP on a single router. You can configure maximum one process of RIP on a single router in IPv4. But in EIGRP, you can run multiple processes of EIGRP on a single router. That is also another advantage of running EIGRP over RIP. That is why in EIGRP we are having AS number to specify its processes. If you are running two different ASs, it means you are running two different processes of EIGRP. And by default, routes cannot move from one AS to another.
Yes.
You will always require to perform redistribution if you want to put your routes from one AS to another AS.
I've seen a router that can configure maximum 30 processes for EIGRP.
Yes, that is.
Is it for only 3 routers or is it for all?
No, it depends. It varies platform to platform. That is also true, that you can run maximum 30 processes of EIGRP on a single device. But those 30 processes can be any number. in between 1 to 64535. Right? And in RIP we were not having any concept of neighborship, but here in EIGRP we have the concept of neighborship. For that purpose it is having some messages like hello messages to form neighborship. Over there in RIP we were having only one type of packet, which was update packet only, but in EIGRP we are having various types of packets like update, hello, update, acknowledgement, query, reply, SIA query, SIA reply. Total 7 types of messages are existing in EIGRP. We are also having opcodes for each type of packet in EIGRP. We are also having opcodes. I will be discussing it with you later on, that we are having opcodes. Like in BPDUs we were having type field. Yes. Here in same manner for different packets we are having opcodes. Fine. EIGRP is a classless routing protocol, but again due to auto summarization it will support only contiguous networks, will not support discontiguous networks. But once you will disable its auto summarization, it will start to support discontiguous networks too. And in iOS 15 by default your auto summarization is disabled. Till iOS version 12.4 it was by default enabled, but in iOS 15.0 and onwards it is by default disabled. Authentication is also there. Now it supports 2 types of authentication, MD5 and SHA. SHA is the latest one, whereas MD5 is the older one, older mechanism, older method to form, to configure authentication in EIGRP. So in EIGRP its default AD value 90 and there will be only 2 types of routes available in EIGRP, either internal or external. For all internal prefixes its default AD value will be 90. For all external, and you can also have summary. For summary its default AD value will be 5. Tell me. So if you are having, if you are going through the EIGRP, we have to discuss about its neighborship requirement, the requirements to form neighborship, types of packets, everything. So let's discuss the requirements for neighborship. So if you talk about the requirements for neighborship, you know very well that AS number must match. K values authentication. Network ID must match, not subnet mask. Then next is what? What? Primary? Anything else? If you have configured static neighbor at one end, then you have to configure static neighbor, your neighbor statically on another end also, on another end as well. If you do not configure static neighbor on both ends, then your neighborship will not come up. Let's say that you have configured static neighbor only on one end, but on another end you didn't configure your neighbor statically. In that case, neighborship will not come up. Understood? If we talk about EIGRP, now we can configure EIGRP into 2 modes. One is, another one is what? named mode. First of all, I will teach you only and only classic mode, and then after I will teach you named mode. I will also discuss the differences in between classic mode and named mode. And also I will teach you that what was the reason so that they launched named mode. Why do we have to configure this named mode in our network? Why is it necessary? So I'll be discussing all these things with you. So let's start it from classic mode itself. So first of all, let's talk about the metric calculation. You know that it uses two types of for metric calculation. It will be using two types of components. Fixed attributes, fixed components, fixed metric. Second, variable metric. Under fixed metric, bandwidth and delay. And by default, it uses only fixed metric or fixed components to calculate its metric. Under variable, it will be load and reliability. Because load can get changed anytime, reliability can also get changed any time. That is why I am calling it as a variable metric or variable components. Whereas bandwidth, whatever you have configured it once on your interface, it will remain same. Delay, whatever you have configured under interface, it will remain same. It will not get changed without making changes administratively or without making changes statically. That is why we do not prefer to use variable components for metric calculation. Like we do not prefer to use, tell me, load and reliability. You know why? Because load can get changed anytime, reliability can get changed anytime. So whenever there will be any change in load or reliability, it means metric will also get changed. It means routing table will become inconsistent. Sometimes its best path will be via another router, sometimes it will be via some different router. So your routing table will become inconsistent if you use these variable components. That is why we always prefer to use only bandwidth and delay. Even Cisco also recommends to use only bandwidth and delay for its metric calculation. And the default formula for metric calculation is what? 10 raised to the power 7 divided by bandwidth. And this bandwidth must be least bandwidth and in form of plus cumulative delay, or you can say total delay divided by 10 and multiply by
456.
This is the smallest formula, or this is the shortcut formula to calculate the metric of EIGRP. If you want to see actual formula for the calculation of metric in EIGRP, let me show you. This is the actual formula. Can you see it? This one. K1 multiplied K2 multiplied by bandwidth divided by bandwidth plus 256 minus load plus K3 multiplied by delay. Brackets are there. So you have to, this is the actual formula used by EIGRP for its metric calculation, because in it you can see that we are also using weight values, metric weights, because in EIGRP we are also having metric weights which are also known as K values, K1, K2, K3, K4, K5. Is not it? Even in wide metric in named mode we have also started to use K6. These are known as k values, or you can say these are known as metric weights. So along with bandwidth to delay, you will also be using these metric weights as well for its metric calculation. However, in previous formula, I didn't use either K1 or any K value. But in this actual formula, you will be using all K values. But here you cannot see, you cannot find MTU. That is why I always says that MTU will never be considered for its metric calculation. It will never participate in its formula, in its metric calculation formula. Even hop count is also not there, yeah?
If we are using like three components, then it will be formula will be same.
Formula, this is the formula, right? It will remain same.
If we are using like all case,
Formula will never get changed.
if we are using three components only,
Then also I'm saying that formula will never get changed. This is the standard formula in which you are having all k values. If you are having any, if you are not using any k value, like for an example, k1 is 0, right? So it will put 0 here in this formula. So forget previous terminologies. It does not mean that if you are using k1 is equal to 0, it does not gives you guarantee that, okay, yeah, in somehow we can say that it will skip bandwidth now, right? But it's not true, because in formula now it will put k1 is equal to 0, and after putting k1 is equal to 0 in formula, then bandwidth will also become 0. There will not be any uses of bandwidth. That's the problem actually. That's why we say that, okay, k1 is 0, it means you are not considering bandwidth for its metric calculation. Because in formula, after putting your k1 is equal to 0 means it will not consider now bandwidth. It will consider only and only, you can see k1 is multiplying your bandwidth. Yes. So if k1 is 0, yes. Right? So this is the formula. See, this is the smallest formula. This is the small formula to calculate its metric. Fine. This is all about the metric calculation in EIGRP. And it is also not mandatory to use k1 is equal to 1 only. You can also use 2. You can put k values, you can change your k values, right? And k values can be configured in between 0 to 255. And k1, if you are putting the value of k1, it does not mean that you are putting bandwidth value, no. If you are putting k1 is equal to 10, it does not mean that you have configured your bandwidth as 10 Mbps, no. That's the only weight value. It will start to use that weight value to calculate your metric. That's the only thing. Fine.
So that's the end of today's video, guys. So we'll be coming back with few more videos of EIGRP. I hope you learned something new today. So if you like this video, please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you later.